Okay, we're moving on to slide 11, and we have a couple of different types of questions here. The first one, it's a little more practice on how to write equilibrium expressions. And then the second one is figuring out what the K value is when you manipulate the equation, and the K will change. Write an equilibrium constant expression for each of the following reversible reactions. Let's look at the first one. I have 2CO gas plus 2NO gas, giving me N2 gas plus 2CO2. Okay, now if I look at this, everything is balanced. So I don't need to balance it, but that's the first thing you need to do, is make sure that your reaction is balanced. And now to write my Kc expression, I know that I will have a fraction, products on top, reactants at the bottom, P comes over R. Concentration, or we can do it either way, but because I have Kc and not Kp, it's asking me for Kc, I would need molar concentrations. Molar concentration, square brackets, of N2. The molar concentration means molarity, so moles per liter of N2 raised to the first power, which I don't write, times the molar concentration, the molarity of CO2 raised to the second power, divided by, because I don't have any more products, divided by the concentration in moles per liter of CO raised to the second power, multiplied by the concentration of NO raised to the second power, because those are the molar coefficients. And this is my Kc. If I were to write the Kp expression, I would do the same thing, but with the pressure. So the partial pressure of N2 multiplied by the partial pressure of CO2 raised to the second power over the partial pressure of CO raised to the second power times the partial pressure of NO raised to the second power. You see that these expressions are very similar. They're written similarly, but instead of moles per liter that we have in square brackets, here we have partial pressures. Let's look at part B. I have solid sodium hydrogen carbonate, okay, and it tells me it's a solid, so I have NaHCO3. Bicarbonate, or hydrogen carbonate, is NaHCO3, and it's a solid. HCO3 has a charge of -1. Na has a charge of +1, so I don't need to do anything. This is a neutral compound. This compound decomposes, so I know that it's not reacting with anything. It's a decomposition reaction. So it decomposes to form solid sodium carbonate. This is a 2 minus. This is a +1. Therefore, to make this a neutral compound, I need 2 sodiums. So sodium carbonate solid plus water vapor and carbon dioxide. H2O gas plus CO2 gas. Now I need to make sure that this is balanced out. Well, I have 2 sodiums over here and only 1 over here, so I need to put a 2. Now let's look at the rest of it. I have 3 oxygens plus 1 is 4 plus 2 is 6. 2 times 3, that makes 6 oxygens. 2 times 1 hydrogen makes 2. There's my 2 hydrogens. 2 times 1 is 2 carbons. 1 carbon here and 1 carbon here. That gives me 2 carbons, and I'm balanced out. So this is my reaction. I need to write a Kc expression for this reaction. Kc is equal to, okay, the molar concentrations of my products, which is H2O, the concentration of H2O raised to the first power, times the concentration of CO2 raised to the first power as well. Notice that that's where I stop because my other two, so my other product and my reactant, are solids and they do not appear in Kc expressions. So this is the only two that appear are my gas products here because I don't have anything else that would appear. My solids would appear as one and they will cancel out. Therefore, this is the Kc expression for this reaction over here. Okay, then let's look at the last problem for this slide. It says it gives me a value for the Kc expression, or the Kc for this reaction. So I have H2 gas plus I2 gas gives me 2HI as well in the gaseous form. And it's already balanced, so 2 hydrogens, 2 hydrogens, 2 iodines, 2 iodines. So I don't need to do anything. It tells me that the Kc value for this reaction at 25 degrees Celsius is 794. Now, what is the value of Kc if I have this reaction? So if I divide everything by 2, okay, plus 1/2 I2 gas gives me HI gas. What is the new K prime C, if you will? That is what I would like to know. Okay, remember that we said if we multiply or divide by any number the original reaction, which is this one, all I have to do is to find the new Kc, K prime, is to take the old Kc and raise it to the power of the number that I'm using to multiply or divide. So in this case, my K prime C is equal to my old Kc raised to the 1/2 power, because that is the number that I used to divide. Okay, I divided by 2, meaning 1/2. And basically all I have to do is take the square root of 794, or basically this is the same thing as 794 raised to the 1/2 power. Same thing. And this gives me 28.18. This is the new value for the equilibrium constant if I have this reaction. If I multiplied it by 2, it would be Kc raised to squared, Kc raised to the second power. If I multiplied it by 5, it would be Kc raised to the 5th power. If I divided it by 6, it would be to the 1/6, etc., etc. So this is how you calculate the new Kc value if you manipulate the reaction by multiplying or dividing by a number.